Hello and welcome to Game Titan. I became interested in trying to create a hash function in Scratch in order to implement a hash table, because my experimenting with recursion seemed to point towards needing a hash table. As I was looking through and researching different hash functions, many of the higher quality ones require a XOR operation. And I wanted to create a video explaining that. But to do that, first I needed to create a way to display hexadecimal numbers, so that's what I'm going to be working on. We made this sprite here. I called it text pixel. Previously I stuck all of these different costumes in it. Each one has a piece of text that I created with the text tool and just a single digit or letter. Hexadecimal numbers have either the standard digits 0 through 9 or the digits A through F, using the Latin letters instead of Arabic numerals. So I created 16 of them, one for each of the digits. And where I'm picking up is here, where I think I was saying that this string of text here is going to be the same. These are the same characters as in the costumes in the sprite in the same order. And by doing this, my hope is that we will be able to change the number of costumes in the sprite later on to include all the letters or lowercase letters or special characters if we're able to draw them. And rather than needing to update all of the code in the sprite, that I would just have to update this one string to match whatever the new costumes are. So that should be easier to edit it later on or change the position of the characters around. I was originally picturing that this sprite could be a way to render every single ASCII character but that was a little bit more than I needed right now, so I'm starting with hexadecimal. So this block right now is going to get the ith letter of this this string out, and that's going to also be eventually when we say switch costume to, we will we'll actually need to get the index in the string of the character that we want. So in addition to letter I of the string, eventually we'll also need to be able to figure out which position within this string. I'm remembering where I was. So we need to figure out which position within this string a specific letter is at. So if we have the letter F, we need to be able to look up within this string the fact that that is costume number 16, and that's the 16th character in this string. Sometimes in some programming languages, you can actually take a character I can't type any letters in here. Sometimes in some programming languages, you can take a character and add 1 to it, and it'll come out to be the next character, but that doesn't work here. Even though in the code that I did see for doing bitwise operations, you could do something like this, and it would interpret this as a hexadecimal digit. So right now, actually, if we had a letter, what we would do is stick the letter in here, like F, do this hack to put the character 0x before the F, which makes Scratch interpret this as a hexadecimal number instead of as the letter F. And then we could look that up in this string here. So for example, if we did this, we want 0 to look up 0, but in this string 0 is the first letter, which means that, for example, if this was 0, then this whole expression would be 0. But we actually want to look up the first letter of the string. So we'll add 1. And now this will find the correct position of this string. That's what this 0x prefix does. The simplest approach for doing this is called a linear search, where you'll loop through this string searching for this value here. So if my value is 1, 2, 3, 4, then this letter I, as we loop through this repeat loop, and remembering where I was, is going to be one of the current letter in the value we are trying to draw. So to figure out which costume is associated with this letter, the simplest thing that we can do is search through this string here, figure out which letter is the right one. So make a new variable to loop through this string. We'll start it at 1. It's the beginning of the string. And repeat until j is greater than the length of the string. So we need to refer to the string several times in our code. So it'd be good to put it in a variable. We'll call it costume letters. And we'll initialize it over here. It's pretty common for constant variables that aren't going to change during your program's run to be all capital letters like this. Just a convention to make your code easier to read. So we have the letters in that variable, and we can refer to it here now. And we'll say the length of costume letters. So j is going to start at 1, and we want to go all the way up until it gets to 16. So when it's greater than 16, which in this case is the length of costume letters, when j is greater than that length, then we'll stop and we'll say if the current letter that we're looking at is equal to what we're searching for, if the current letter is equal to, let's say we're looking for E as an example, then we would know the costume that we want to switch to is J. So we could actually switch costume to J. Let's see if that worked. I'm not sure if that did. grab the logger that we built in a different video. Set this to a higher value. Show it. And then in here, should be able to call this logger function now. Oh, I forgot to add 1 to j. So it's always 1. That's why the function was running forever, or the block of code was running forever. Set, change j by 1. Put that on here. Here we go, that's B. Try 0. Try F. Actually, after we switch the costume, we can exit out of this loops. Exit out of the loop by making j much bigger. Sorry, I wanted the length. There. Let's try that again. F and C. It seems like it's working well. So now we can stick this in here, and the letter that we want to draw is not just only C, it is the ith letter of the value that we are displaying. So we similarly forgot to add 1 to I here. That's going to go after this loop. And then we can drag this in there and this whole thing in here. You can see that's drawing 1, 2, 3, 4 over and over again. But unfortunately, our frame rate has dropped quite a bit. Don't need that anymore. No, I'm not sure why that is. I feel like I've seen Scratch able to switch costumes more often than this. And this way of searching through costume letters is not very good, because when we have the letter F, this loop here will actually run 16 times, which might be slow, but switch costume should only get called once. So this is a little bit surprising to me. I think I know what the issue is. So this block of code is just getting called directly from this draw event. We did not actually create a custom function that has the run without screen refresh checkbox clicked. And so I think what's happening is, as this code is running, it's refreshing the screen more than once, as opposed to just only when switch costume is called. So let's try this. Right, that does seem better. The costume's not actually changing, but the frame rate has increased quite a bit again. So that's good. Now we actually need to move the sprite each time through this I loop. We don't want the sprite to keep moving to the right, so we need to save the original position, which we can grab here and here. We'll need to save them in some variables. Old original x and original y, and we will drag them in here like so. And after we save them, every time we are going to switch costume, because we know what character we want to show, we will move X by some amount. Just try that out. Although likely we will want a character width we can leave this displaying here so that we can play around with it, and then here we'll change X by character width. And what I was playing with earlier was this stamp functionality. I can demonstrate that really quickly here. As you keep calling stamp, it will keep stamping out more copies of your sprite. There's some effects that you can do. I think they're in looks. For example, we could do this and then stamp. You can see that the color is changing. Maybe make it a little bit more subtle. Maybe change the size of the sprite so that it's easier to see. You can see that the color is changing. So, one possible way to approach this would be as you could actually just see there. That's a little bit hard to grab. As you can see here, I did not actually set the X and Y position back to the original at the end of the draw function, so what happened was the number scooted across the screen because it kept running this code. And there's nothing at the end to bring it back to where it was originally. So we can do that really quickly. Where we go to the original X and original Y. Like that. And then hopefully no matter where this sprite starts out, it will stay right there. So one thing that we would do is to stamp. That worked. The character width is a little bit too small. I suppose that when we initialize, we actually need to erase all. still not wide enough. That's too wide. Let's make this a little bit easier by putting an erase all in here for now. I think if we set the ghost effect, the stamp might still actually work. So that we don't have to call both show and hide every time. Oh, we don't change. No, that didn't work. So we actually do need to show and hide. What if we just hide it? Oh, that worked quite well. Our frame rate is still okay. I wonder if there's anything that we can do to recenter that 2 or the 1 spacing looks. That looks better. So we don't need that anymore. We don't really need to display these. I don't really need these. As we change this value, you can see the numbers updating. As the number is changing around, the frame rate is still, the number of times that we're being able to call draw is still pretty good. So that means draw isn't taking up more much more than a really small fraction of time that it takes up every 30th of a second. What we have not done yet is try some values that have some text in them. That worked pretty well. Right now we're calling erase all every time we pass through this draw function. That could potentially be problematic if your program uses the pen for anything else. It would be nice to make this more reusable, have maybe like a pen, some kind of pen erase phase in here. I imagine that the pen is only something that runs every 1/30th of a second. I'm not totally sure how to test that out. Stamp. I guess we could do that by removing these movement blocks here, as well as this one. And then I'm not sure if querying the X and Y position also causes a screen refresh. So here now we just have variable operations and this one stamp call. And if the stamp call causes a screen refresh, and we move this code to run in the tick event instead. Tick event instead of the draw event, just to make the test more comparable. We'll make a function. Then we would expect that the frames would drop to 30, which it does. So just something about calling either erase all or stamp. Yeah, so stamp definitely will trigger a screen refresh and slow this event loop down. I guess we can be totally sure by doing that. And we can see that it is actually much faster. Although you can see that this code is actually slow. It's this searching through the entire costume letters string that's slow. So back up these changes, get this out of tick, put these back on top. Make sure that we switch costumes before we stamp, and restore the position afterward and hook it back up to the draw function. So, since these pen blocks do block, they do trigger a screen refresh, we want them to run inside this slow part of the game loop. So we can make a erase all. And we'd want to do that every time, I think, before we did drawing, so that whatever was drawn could stay on the screen all the rest of the time that tick was running until the next timer trigger. So add a erase all handler like that. You can make an erase all function. And then we can just stick this in there. Unfortunately, that doesn't work because after this broadcast is finished, the screen does get refreshed once. You can see that this is 15 now instead of 30. totally sure what to do about this yet. It's not a problem right now, but it makes the sprite a little bit less reusable. You can imagine the problem would be that if there's multiple sprites that use draw and one of them is erasing all, and it happened to run after another sprite that was also using the pen, then the sprite would erase all of that sprite's work. Which is a little bit unfortunate. Let's just clean up the code a little bit so that this is a bit more reusable. If there were a way to unstamp, we could get rid of this erase all and first undo the previous stamping before we set the new one, but I'm not aware of anything like that. I think this is pretty usable for now. I'm going to put it in my backpack. Just picking a different name that I'll remember more easily. So what I'd been hoping to do with that sprite that we just built was to make a little toy where you could put in a value and it would show you, you could put in a number and it would show you the number in binary and hexadecimal and decimal all at the same time. So you could play around with it and see what the relationship between the three base systems were. Just add a few utility code, get rid of the cat. So the way I guess this would work is that maybe there's a main value that's being displayed a global variable that several of these text sprites will look at. This one will be displayed value, something like that. And we'll have a few copies of this text sprite. So this will be the decimal version. And every time we draw, we'll say set the local value, that's the one that's inside the sprite only, to this global displayed value. Maybe I'll even call this global, because it's used for all the sprites. We forgot to set character width in our other project. Let me just fix that in here real quick. So the decimal version of this is pretty easy. We already had finished this before. Now we should make the other two. This will be the binary. Now with binary, the value that we're going to set is going to be I think the easiest way to do this in terms of writing the code is to look at whether or not the last digit is, whether or not the decimal value is odd. Reason being that all of the odd numbers are going to have a 1 in their last binary digit, and all the even numbers are going to have a 0 in their last binary digit. So we'll say we need like a temporary copy of global displayed value that we're going to destroy. We'll call this temp. We'll start out by saying temp is equal to the global displayed value. And then what we'll do is successively pull off the last bit over and over again until temp is empty, and tacking them on the right side of value each time. So to find if it's even or odd, we can use mod we'll say temp mod 2. You can even just stick it in here. So temp mod 2 is going to be 0 for 88, and for an odd number like 27, it'll be 1. And then this will be the right-hand side most character of value. So we'll say set value to the empty string at first, and then until temp is 0, we want to keep pulling the last bit off of the right end of temp. So repeat until temp is equal to 0. For value, we'll take the value it had before, and then we'll want to take whatever bit we're pulling off and sticking it on the left side. So we'll join value with this, and then that's running forever because temp is never getting to 0 right now. And then to cut off this last bit on the right side, we need to divide by 2 and round down. I don't know what this round does, so if we had 0.5, that actually rounds up. I think I saw a floor function in here. So floor of 0.5 is 0. The floor of 1 should be 1. So we can take the floor of temp divided by 2. This will be the new temp. Alright, now does that make sense? It makes sense enough that we can stick it into this loop at least. So if value is 21, oh, we just have this extra block here. Well, there's one issue, which is that when value is, let's see, if we have 0 here, does that work? No. So if temp is 0 initially, we still want to stick a 0 in there. If temp is 0 initially. So I say if temp is 0, then Well, I think we basically want to run the same code. Seems like there has to be some way to simplify this. Well, we know that initially value is the empty string, and we don't want that. So if temp is 0, we exit. And we also need and. So when temp is 0 and value is not the empty string. Value, where is this? Value is not equal to, value is not equal to the empty string. So if both of these things are true, then we can exit. So if value is the empty string, we'll still run this once. And if temp is not 0, even if value already has something in it, we will still run the loop too. It should be better. That seems to work. Let's hook it all up and make sure. That's pretty good. Now we're running into that issue I was mentioning earlier where the erase all on the binary I think is interfering with the decimal. So if we can test this out by detaching this, and then the decimal will start showing. Once we attach this, then this erase all is actually erasing the decimal. You can see that stamping the same costume over and over makes them look a little bit thicker. Oh, general awareness. Sent a chat. I don't know how long ago that was. He said, this stuff I don't get. Is it a finished product or is this for academics? This is not a finished product. But I was hoping to create a little toy to make a video to explain what's going on. Because I need some of this stuff to build up a hash function, which I'm going to use to try to create a hash table, which I'm then going to try to use to speed up something I did in another live stream where I was playing around with recursion. So it's kind of dry right now. Alright, so the last thing we wanted to do is make a hex. Similarly with the binary, this actually should be pretty easy. So we'll chop off the last 4 bits each time, and 4 bits is 16. Oh, of course. hexadecimal. Then we need to convert so this thing we need to convert into hex, so that's where this string will come in. We want this letter something of this string over here. I don't know, my piece didn't work. So this is going to be 0 when temp is 0, but the first character in this string is character 1. So to add 1 to this and put it here, and then stick that before the value. Not having the erase block is causing an issue. I wonder if I can just stick it in here. Oops. Erase all. It works! Why did this work and the other thing didn't work? I don't understand. Let's move this over here. Hey! This is working. This slider's a little bit hard to use. Can I make it bigger? I just thought of a really ugly way to do it, possibly. Right. I don't know what to call this project. Different base number bases. Your frame rate's still pretty good. Let's hide these variables. Temp, binary temp, binary value, and decimal value. We should probably label them. Decimal. Oops. This is really hard to grab. And the binary. And then hex. Alright. I think I can play around with the layout a little bit more, but this is roughly the toy that I wanted. So the decimal lines is displaying the number the way you'd normally think of it, where 1 just looks like 1 and 2 just looks like 2, and so on. You probably remember from school that as you count up, you get to 9, and we run out of digits at 9. So instead of making up more different digits, we just start reusing them, but having more than one of them. So this means 1 of 10s and 0 of 1s. And if you keep going up, then you get to 99, and then you get 1 of 100s and 0 10s and 0 1s. Binary and hexadecimal are just different ways of writing the same numbers, which look different and just run out of digits faster. So binary just has 2 digits, 0 and 1. The bi refers to the fact that there's 2. The deci here refers to the fact that there's 10 digits for decimal, 0 through 9. And so what happens, you count from 0 to 1 and you run out of digits, and you can't reuse any of them. So when you get to the next digit, you overflow into the next place value. So here you have what looks like 10, but actually means there's 1 of 2s and 0 of 1s. Then you count up to 3, that's 1 2s and 1 1s, and then again you run out, so you have to use another third digit. So this is now saying 1 of, not 100, but it's actually saying 1 of 4 plus 0 2s and 0 1s. And then similarly here you get to 7, and you run out of digits because there's only 2. So you have to use a 4th place value, which is now saying there's 1 8, 0 4s, 0 2s, and 0 1s. The reason binary is important is because computers use electric signals to represent numbers. So even though the computer knows to display this 2 here as a font glyph that looks like the number of 2, actually internally there's 8 binary digits, or potentially more these days, that represent that 2, and it gets translated into this somewhere in many layers in the operating system and your web browser. And then hexadecimals, actually just the same idea, but instead of 2 different digits like in binary, or 10 digits like in decimal, hexadeci stands for 16, so there's actually 16 digits. We don't have any digits after 9, so someone at some point decided to make the 10th digit A and the 11th digit B, C, D, E, F. So when you see A, that actually means 10, B means 11, all the way up to F, which means 15, and then, only then did you actually run out. So the next thing, if you think, what do you think the next thing is going to be? When we overflowed here, we added a new digit. When we overflowed here, we added a new digit. So the same thing happens here, where we ran out. So we'll actually do 1. This is not a 10. This means there's 1 16 and 0 1s. And then similarly here, you get to 1F, which means 1 16 and F 1s, which is 15, so that's 31. And then when you overflow, we still have more digits in this 16th place, so we actually can go to 2 0, 2 16s, which is equal to 32, and 0 1s. So I guess that's enough of a toy to be able to make a video about this. I think I'll stop here. I hope that was useful and interesting, and if you're watching this later on, please subscribe to the channel and hit the like button on the video. I'd really appreciate it. And thank you for watching, and I'll see you next time.